Oh, no, not this one. Hello, everybody. This is Professor Ma, and these sections are integrations of the products of sines and cosines. And so we went through different integration methods, and integral problems in general is a lot harder. So the way we approach integration problems is by integrating by types. Okay, we find algorithms, or that's in other words, methodical ways or recipes for dealing with different types of formulas. In particular, we're going to we're going to talk about the integrations of products of sines and cosines, including negative products, meaning, secant, cosecant, etc. But since everything can be converted into sines and cosines, so therefore we're going to look at the products of sines and cosines. Okay. The place we start is where we stopped last time. That's we have these reduction formulas. Okay. And I want to point out a couple of things about these reduction formulas. Okay, and first of all, the notations, and that is we're going to use E for secant. Okay, so everywhere you see E, that's secant. So that's a reductive formula for secant right there. Okay. Secondly, all these reductive formulas start with the positive integers, and then it reduce the positive integer by 2. Okay, until it gets to, for instance, in this case, until it gets to 2 cases, it gets on to integral of a single sign, then the answer is going to be minus cosine, then the process ends, or it becomes s to 0 integrating the constant 1, then the answer is x, and then the answer ends. Okay, so this is how this reductive formula works. So what we're going to do is we're going to first go over one more times all the basic formulas for trig integrations of sines, integral of sines minus cosine, integral of cosines minus sine. Then we have two more, integral of tangent is log, and integral of secant is another log. And let's see how these are done. How to integrate tangent? By the way, once you figure out how to integrate tangents, well, basically it's substitution method, because the derivatives of the cosine is the sine, and sine dx over here, the sine, once you change into du, the derivative will be canceled automatically in the algebra. So as we go through, the sine cancel, that's where we get the log answers. And for integrating secant, we multiply the secant by this strange term. Okay, and the consequence of this is actually we wind up with the following, and that is similar to the derivative of this actually is the top, because derivative of tangent secant squared, derivative of secant is secant 10. Hence, we can use the substitution method. Okay, so this is sometimes a standard trick dealing with secant. Okay, to get these integrations workable. And by the way, both of these examples, you can for integrating cotangent, cosecant, the process are the same. Okay, then you just come up with a minus sign, a different sign. Okay, leave that up to you. Okay, now let's integrate the squares formula. Or the square formula, as we mentioned before, we can use the reduction formulas. Okay. We can promote a square formula over here, then we wind up with 0 power, then the answer comes out. In particular, In particular, if I use the square formulas on, let's just do 1 sine square, then this will be sine to the first 2 minus 1 to be first power divided by 2. 2 minus 1 is going to be 1, 2. And then sine square 2 minus 2 is sine to the 0 power, and integrate of this is just 1. Integral of 1, then this entire thing's x. So the answer is going to be minus sine cosine over 2 plus 1/2 times x plus a constant. Okay. K, let me use K so you wouldn't confuse C with K. Okay. So that's one way to do it, but another standard way to do these things is use the half angle formula. That is, we convert square terms of sines and cosine into linear terms of double angles. So I don't have to deal with square anymore. I can integrate the linear terms with no problem. It's easy linear change of variable. So this is another way to integrate the square terms of sines and cosines. Okay, and sine square similarly, you put into the double angle formulas, converted them into double angle formula. Antiderivative of secant square, oh, that's tangent. Antiderivative of tangent square, and here's another standard trick. We have an identity that can convert tangent square into secant square, which we can integrate. So if we convert it, and that's going to be tangent minus 6. So here are the summary of the all the linear terms and the square terms. Okay. Yes. Now we're going to integrate all the products. Okay. And so in particular, we're going to integrate the products of sines, and we're going to integrate these 3 different groups. Okay. Excuse me. Okay, so now we're going to integrate this product of, let's start out with the first one, the product of 2 positive integers multiplied, okay? And the trick of over here is if I multiply powers of sines and cosine, as long as one of them is odd, okay, in this case, the sines are, the trick is split out 1 copy of it. And then the rest is even power, right? And I convert the even power s squared into cosine. If you know, whatever this r power that splits out, you know, if in general, if it's r power, then I can write this as sine times 1 minus cosine squared to the kth power. Okay, so I can split out 1 copy of the sine. And the reason we split that copy off because now I can use substitution method, derivative cosine sine. So the substitution of u to be cosine. Okay, and then everything goes through. Another way to do this, if suppose that's an even power square, another way to do this is convert this into a cosine problem completely, because even powers of sine, I can convert it into cosine completely. In this case, it's 1 minus sine square, cosine square, and then you multiply it out. It's a polynomial in cosine. Okay. Another little trick over here is in this particular case, I have everything in cosine odd power. So I can pull out a copy of cosine, which left me everything in cosine even power. And then I can convert the cosine even power back to sine. And then, so I have one copy of cosine where everybody else is in sine. Then I can use substitution because derivative of sine is cosine. So if you can split out one copy of sine or one copy of cosine and change everything else to the other one, you have it done, because then you can make a substitution to cancel out a single copy of sine or cosine. Okay, that's one trick. Kind of keep that in mind. So I'm going to make the substitution, u to be the sine, and then the cosine will be gone in terms of integration in du of the substitutions. Okay. Now, then what happens if both are even? Well, both are even, then like I said before, you change everything into cosine, then derivative of cosine square, like this problem, cosine square is this using, cosine square formula, and cosine to the fourth, they use reduction formulas. It comes out to be that, I'm subtracting that, and then you combine like terms. Okay. Oh, by the way, this is just one way to do it. There are many different ways to do it. There's another way that you use multiple angle formula and examples like that. Okay, so here's the summary. If one of them splits off a copy of it. If both are even, then converted into one type, and then you use reductive formulas on every one of these terms. Right? It might be lengthy, but it's a sure way to get answers. Okay, so that's how we integrating positive products of sine and cosine. One way to do it. Now, how do we do it if I do a fraction where one of them is on top, one of them is on the bottom? Well, it's similarly, okay? We look at the top powers. Over here, let's assume the top is the sine, and so let's assume it's sine. So I'm looking at the power of sines, which is m. Okay, like before, if that number upstairs is odd, okay, then I can split out a copy of it. Okay, in this case, let's say it's supposed to be odd, and then I can convert the rest into 1 minus cosine squares, blah, 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 to the k, some k power, and divided by cosine to the end, okay. So I can convert this into that, okay, into all of these. That is, if the upstairs power is odd, we can split out a copy, okay. So let me, okay. Okay, like here. So I'm going to split one copy of the sine, and the sine square is 1 minus cosine square, so convert that into cosines. And now the derivative of cosine is sine, so I can set u to be that. Okay, so cosine prime is equal to, so. And it will guarantee the sine will cancel out when I change into du, which it does, okay, because du over sine. Okay, and the minus sign over here, I switch this around so it's absorbed into the subtractions. Okay. And now it becomes a basically an integration in u, so you integrate in terms of u. Okay. Now, then the other case, what happened upstairs even power? Okay, well, then you convert into cosine completely, just like the case we did for both positive integers, okay? And then in this case, you're integrating secant, power of secant, right? Because everything's in cosine divided by cosine to a single power. So if I need to, I'm integrating power of secant, that I use the reduction formula for secant until the answer is done. Okay. So that's basically how we deal with those cases. Then there's one single case is what happened. I'm dealing with both sines and cosine on the bottoms. Okay, there are different tricks dealing with these, but we will look at that. Another technique we call partial fractions, and to do with integrations of rational formulas, and then we'll take a look at these. Okay, and that's these sections. Okay, bye bye. Until next time. Bye bye.